Amber?
Thanks, Mark. So we want to now take that data that we've generalized over Frankfurt and produce something that looks like a printed cartographic product, right? So how did we produce this PDF? If I jump back over into Arcgis Pro, what we're now looking at on the left is the data after it's been generalized, and on the right is the exact same data after we've performed our automatic cartographic finishing techniques. So if we take a look at some of the differences between these two, the first thing that you might notice is that some of the symbology has changed just a little bit. It takes a little longer to draw, but you can see now that as we have each road junction, that the symbols look connected. And that's just a symbol draw option and technique that you can turn on and off for your layers. But it gives a better cartographic appearance and allows you to show features that are over and under others. Additionally, you may see some other things showing up here that aren't in the generalized data. So you can see all of the different grid lines that are showing up. Again, this is cartographic data that we produced that we didn't need in our GIS database. You can see that there's some text showing up here as well. Again, these are attributes of the data that's already there that we've just decided to label and display as annotation. Additionally, if you look pretty closely here, you might notice that we have contour lines. And again, those didn't exist in our base scale data, but we can depict elevation information as well in our cartographic product using something like contour lines. So we've produced all of this additional information that goes into our cartographic product. And additionally, you can see some of the other ways that we've refined the appearance of the data. So we look in this area, we're outside of a built-up area. And so we've kept a significant number of our buildings outside the built-up area. The density of those buildings is correct for our 1:50 scale database, but once we apply these big black square symbols, you can begin to see that they feel cluttered. Some of the symbols appear to almost draw on top of each other or draw on top of the roads. So we want to perform some cartographic conflict resolution to produce a result that looks cleaner, right? So you can see that as we have this dense cluster of buildings, in the output, there's not quite as many. We've hidden a number of those buildings. We've shifted them a bit away from each other, shifted them away from the roads, and also performed rotation so that the buildings align with the roads. And all of that happens through some automated geoprocessing techniques and tools, just like we did with our data generalization. To point out another area where we've performed some automated symbol adjustments, let's look at our bridges. So by default, our bridges are points, and our point symbols are rotated horizontally, and there's not much spacing between the right and the left side of the bridge. Now, again, using a geoprocessing tool, it can identify the feature that overpasses another. So in this case, the road that overpasses the river, and it can rotate the symbol to that overpassing feature and spread the sides of the bridge so that it's wider than that symbol, the road symbol. So you can see that this bridge is spread further than this one. You can see the rotation angle applied to some of these bridges. And again, these are just various techniques that can be automatically applied to your data. Once you've performed all of the techniques and run all the tools that you want to refine the appearance of the data in the main map, that's where you begin to construct your layout or apply your data to a layout and potentially update some of the information that's in it. So in this case, our map has a title, some information about the country. You can see that all of the data, including our grids and our annotation, all of our symbology has been applied. If we zoom in a bit, you can see that there's other information being depicted here. Some of the things that we did automatically is creating this magnetic north arrow. So this north arrow tells us what the magnetic declination is of this sheet if I need to use it for navigation purposes. We can automatically project our map frame as well. So our data started in WGS 84 and was projected to the appropriate UTM zone. Again, all automatically happening. Some elements may be more static in our map, so our scale bars and our legends may not change from sheet to sheet. But then there's other information like what are the map sheets that are around my current extent? Or what are some of the key features that are around my current extent? And all of these, again, can get added to a layout and automatically updated using either geoprocessing or Python tools and techniques. So in this demonstration, I showed you how you can take that best scale data. So if we flip back over here, we've gone from something that looks like this to something that looks like that and put it into a map, right? And again, all of the ways that we did this were automated using geoprocessing and Python.